So the goal of today's video is to talk about a particular kind of integration problem called an initial value problem. And an example of such a problem is given here. Find a function capital F of x satisfying capital F prime equals this polynomial, and f of 0 equals 7. Now, notice what capital F of x is in this problem. Capital F of x has a derivative equal to this function. So in other words, capital F of x is an antiderivative of this function. But there are an infinite number of antiderivatives for any function, because any constant multiple added to a particular antiderivative will still be an antiderivative. So the question is, of all that infinite collection of antiderivatives, which one satisfies this second property, that capital F of 0 is equal to 7? So we begin by finding the indefinite integral of 3x to the 4th plus x plus 4. We find the indefinite integral. We find the general form that describes all antiderivatives of this function, and then we're going to try and take that general antiderivative and find the specific one that meets this second condition here. So let's once again use power rule in reverse. 3x to the 5th divided by 5, increasing the power and then dividing by that increased power. X squared divided by 2. And what would give me a derivative of 4? A linear function of slope 4 would give me a derivative of 4. Then, to give us the most general antiderivative, I will put plus c on the back. Now, my f of x function is going to have this format. So let us then plug in this information about f of 0 equals 7, and let's see what that determines about the value of c. F of 0. 7 is equal to what you get when you plug 0 into x's place. 0 squared over 2 plus 4 times 0 plus c. If I simplify this as much as I can, all the 0 terms vanish, and I am left with 7 equals c. So, by plugging in that given point, f of 0 equals 7, I've determined the value that c must equal. And therefore, I can conclude that the f of x, the particular antiderivative that they're interested in, must be 3x to the 5th over 5 plus x squared over 2 plus 4x plus what we now know to be 7. What we now know to be 7. And now this would be my final answer to this initial value problem. Don't just give me any antiderivative, give me the particular antiderivative that goes through this point. Now I think the temptation, especially when you see this kind of initial example, is to assume that the value of c will always be equal to the given output here in the initial value problem. But let me do a second example to show that that's not always the case. Second initial value problem. Find a function capital F such that f prime is sine and f of 0 is 4. So once again, let's start by finding the most general antiderivative of sine of x. Not quite cosine of x, because if the antiderivative were cosine, the derivative would be negative sine. So instead, let's put a negative sign here on the antiderivative to counter that. And of course, our beloved plus c on the side. This is equal to f of x. Now, let me go ahead and plug in x equals 0 for x and 4 for the output. And it says that 4 should be the result if you plug 0 in x's place in this function. Now cosine of 0 is equal to 1, which means that I now have to solve this equation for c. c is equal to 5, 4 plus 1. So c was not equal to 4 in this case. C was being affected by this cosine, and we have f of x for this problem is negative cosine of x plus what we now know to be c equals 5. c equals 5. So here is the general process. For an initial value problem, start by getting the most general antiderivative, and then use the given point to calculate the value of c.